Hey, welcome back, everybody. I'm here with Hossam, engineering manager at Willow. Hassam's here to tell us about build your Azure infrastructure as code with .NET Core, which actually checks all of my boxes as both a .NET person who loves Pulumi and infrastructure as a code. So I'm personally excited for this talk. Hossam, why don't you go ahead and tell me all about this?
Thanks a lot for the intro. Thanks everyone for joining us today. My name is Hossam Barakat, and I work as an engineering manager with a company here in Sydney, Australia called Willow. We are building digital twins for infrastructure and real estate buildings. This is my Twitter handle and website if you would like to follow me or reach out to me with any questions. Today, I would like to talk to you about building infrastructure as a code solutions that would provision Azure resources with .NET code. I'd like to talk a little bit about the history. How did we end up with infrastructure as a code solutions in the first place? Historically, we used to deploy our infrastructure as servers or virtual machines on servers inside data centers of our buildings. Over time, we moved to cloud. So we started moving our applications to cloud platforms such as Azure, GCP, or AWS. And all of us started by asking, okay, I would like to provision a virtual machine or a web app. How would I provision that resource? Most of us started by using the manual or the ClickOps approach, where if you would like to provision a virtual machine, you will open a form, you will be asked for the memory size, the hard disk size, and the CPU. And then a few other parameters, you click create. A few moments later, you will get your resource ready to be used. Usually our applications doesn't consist of a single resource, it contains multiple resources. So over time, we started to realize that manual or ClickOps approach is kind of a difficult approach to use because it introduces the issue of Snowflake servers. Snowflake servers are basically the servers that are hard to reproduce. So we ended up with situations where we have a production environment, and that production environment is set up and configured in a way that's different from the development environment. This usually led to bugs that are hard to reproduce, hard to troubleshoot, and to resolve. As a community, we started by moving into the infrastructure as a code solutions. And we started by what's called imperative approach. But what is infrastructure as a code? Infrastructure is, as an idea, is pretty straightforward. We manage and provision our cloud resources using code. So we started with the imperative, which is basically we have a bash script that is full with CLI commands or PowerShell scripts to provision the resources. So we end up, if I would like to provision a virtual machine, I will have a one line in my bash script that will create the virtual machine. I pass multiple parameters such as a CPU, memory, networking configurations, and so on, and then the virtual machine will be provisioned. As the solutions get more complicated, that script will have more and more commands inside of it. That was a big improvement from the ClickOps approach because I can rerun this script multiple times. But like anything in software, sometimes we have bugs or some exceptions that could happen while we are running our scripts. And when that happens, my scripts need to be reliable and it needs to be able to handle the errors. So if I have a script that is like 40 lines of commands, and then my script failed at line 20, I should be able to handle that exception. And even better, I should be able to rerun the whole script so that I can provision the rest of the resources without ending up with duplicate resources for the resources that have already been provisioned in the previous run. So as you can see, the more concerns that I have, the more complicated the script become. And as a community, we started to see a lot of very complicated bash scripts or PowerShell scripts to provision the infrastructure resources. So that led us into doing what we do best, which is applying abstraction concepts on all of those common concerns. And that led us into the declarative infrastructure as a code. The declarative infrastructure as a code idea is we would like to have all of these concerns of detecting the changes, making idempotent scripts, error handling to be abstracted in a tool. And as developers, our responsibility became just writing the desired state. What is the end state should look like? And then it's the tool responsibility to determine what kind of changes or what kind of actions needs to happen on the cloud platform to reach to that desired state. There is multiple infrastructure as a code solutions available right now, such as Azure Resource Manager, Terraform, Bicep, AWS CloudFormation, and a bunch of other tools. And all of them are great and provides a lot of like improvement over the imperative solution. However, for me as a person coming from a development background, I found that those solutions are not really intuitive for me, because most of those solutions are written, I need to write my infrastructure as a code in JSON or YAML, or I have to learn a specific domain, a domain-specific language, such as Terraform, HashiCorp language, and similar other tools that you need to learn the like totally new language, how to declare a variable, how to declare an array, how to do a for loop, all of these. And it's not like writing a real programming language. It's just, it's totally different. So it wasn't as intuitive for me. The good thing is there is a different approach that we can use to provision our infrastructure resources. There is a tool called Pulumi, and Pulumi is an open source infrastructure as a code tool that enables us to leverage real programming languages such as C#, TypeScript, or Go to provision and manage cloud resources. And this is what I'm going to show you today. I will be focusing on using C# and with Azure Platform to show you how we can use Pulumi. But before I show you Pulumi in action, I would like to go through the benefits of using real programming language. Just making the decision of using real programming language provides a lot of benefits. So if I would like to have a for loop, I just use a for loop, or a while loop. It's just out of the box. I don't need to learn something new. If condition, it's just there for me. If I found or if I built something that could provide value for other team members or could be reused, I can apply abstractions with the common tools that I have, such as functions, classes, and packages. If I found that that is beneficial for other teams in the company, I can package it with NPM or NuGet package and share it with other teams in the company. This is out of the box. Those tools are already there, nothing new. I'm just leveraging the existing capabilities. I can write the infrastructure as a code in my favorite IDE, be it JetBrains Riders, Visual Studio Code, Visual Studio. I just use that tool that I prefer to write my code in. And with the static type language, I can get code completion, I can do refactoring easily, I can do static type checking, all of this out of the box. If I would like to write tests, I can write the tests using my favorite frameworks, XUnit, NUnit, Fixie, whatever you prefer. All of these benefits just because we decided to write the desired state using real programming language as opposed to YAML or JSON or a domain-specific language. So as a person coming from a development background, this resonated really well with me. So I'd like to show you Pulumi in action so you can see all of these benefits for yourselves. The first step to use Pulumi, you have to install the Pulumi CLI, which is a cross-platform tool that enables us to provision resources to scaffold the new project with Pulumi. And the first command to use is Pulumi new. Pulumi new will show me a list of templates that I can use to start my project with. Today, I will be using Azure with C#, and then Pulumi will ask me for a few questions to scaffold my project. I will go through what are the values of each command here or each question later today, so I will just keep the default values for now. And this is going for, because I'm using the C#, it's going to provision a console, a .NET Core console project that includes a few commands for me that I can use. So let's go and open Visual Studio Code to walk through the files that has been provisioned for me. So first of all, this is called a Pulumi project. And any Pulumi project will have a Pulumi.yaml file. This Pulumi, I know there is irony here, it's a YAML file again, but it's a really small YAML file. because we only have the key part here is the name of the project and the runtime. Because Pulumi supports multiple runtimes, we need to tell the Pulumi CLI what kind of runtime this project is based on. In this case, it's .NET. I have another YAML file, which is the configurations for Pulumi stack. So this file enables me to change the configurations of my code or pass parameters to my code. So for example, if I would like to provision my resources for the development team in Australia, I can change the location to be Australia East. And for the for production environment, because the end users are in US, I can make this West US or East US based on the users. I can change these configurations. Or for example, I can change the size of the CPU for the virtual machine to be large for production, but small for development environments. This is my .NET Core project. It's .NET 3.1, and it refers one package from Pulumi, which is Pulumi.Azure Native. My program has one line of code, which is the main method with deployment.runAsync. This is a class from Pulumi, and it's basically running or creating the resources that exist in my stack class. My stack is a class that inherits from a base class called stack. This is from Pulumi as well. And in the constructor of this class, here we are provisioning all of the resources. And as you can see, to provision a resource group, it's just a new class instance. So I create a variable and give the new resource group, give the name of the resource group to that class. I would like to provision a storage account, another class instance, give it the name of the storage account, and then the other parameters such as stock keeping unit, where does that storage account will be hosted, which resource group. As you can see, I'm just to refer to another variable, it's just as intuitive. It's another variable, you use the other variable. The last part is about output properties, which I will cover later today. Just to keep the first demo simple, I'm gonna remove this output property. I'll cover it later in the session. So as you can see, we have two resources, a resource group and a storage account. So that's the code. How would I actually provision these resources? I'll provision these resources by using the Pulumi CLI, and I will use a command Pulumi up. Pulumi up does the first thing, which is previewing the changes that are going to be applied if we were to run these commands. So right now it's looking at my code. This is a desired state, and it's telling me if you provision, it will create two resources, resource group and a storage account. I will go with yes. This is going to provision both resources for me. You might be wondering right now, okay, how did Pulumi know which Azure subscription to connect to? And Pulumi will use your current credentials for Azure CLI, because I have already logged into my Azure account on this terminal previously. It will be using that to provision the resources and to know which subscription to connect to. If you would like to change to a different subscription, you can also pass different parameters via environment variables to Pulumi CLI to know which Azure subscription to connect to. As we can see, the resources has been provisioned. So I'll switch to the Azure portal. I will refresh here, and I can see the resource group has been created. You can see here that Pulumi automatically added this random string at the end of the resource name. This is to avoid collision. If I would like to run that script multiple times, each time it will add this random string. If your company have like a naming convention and you would like to avoid having that random string, that's also option. You just need to update your code to avoid having this string added at the end of each resource. Let's refresh here to see the storage account. Storage account is available here. As you can see, there was like a delay for a few seconds for the storage account to appear in the Azure portal. Keep that in mind. Sometimes the Azure portal is not up to date, and it takes a few seconds for some of the resources to appear. And here is my storage account. After we provision a storage account, we usually would like, or any resource, we would like to update those resources for the business needs. For example, in this case, If I would like to update the replication from locally redundant storage to geo-redundant storage, just to increase the availability of that storage account, I can easily do that by updating my code. So I need to come back here. I will use the stock keeping unit of geo-redundant storage. And as you can see, I'm using Visual Studio Code, and the IntelliSense is giving me that code completion options of all of the available stock keeping units for the storage account. And I didn't need to do like if condition, if the resource already exists, or if the resource locally redundant storage, then I change it to geo-redundant storage. I just need to describe the end goal, which is geo-redundant. We'll save, and to apply the changes, I will use the same command, which is Pulumi up. And this will show me what kind of changes will be applied when we proceed with that change. So it takes a few seconds to evaluate the delta, and I will show the details in this case. As we can see here, it determined that there is going to be an update happening to the storage account, and that update is changing the stock keeping unit from locally redundant storage to geo-redundant storage. I'll go and proceed with that update. You need to keep in mind that you always, when working with those infrastructure resources, that you usually would like to review the changes that are going to be applied, because sometimes with some of the configurations, it doesn't become an update, it becomes a replace, which means the old resources will need to be deleted first. Here we go. If we refresh, we should be able to see, here you go, geo-redundant storage applied. If I don't need these resources anymore, I can use a command called Pulumi destroy, which will go and remove all of the resources from my Azure subscription. All right, let's get back to the slides to recap what we have learned so far. Pulumi fundamentals are pretty simple to learn. The first thing that we have done when we used Pulumi new, it created a Pulumi project for us, which is the directory that included the Pulumi.yaml file. And that Pulumi.yaml file told the Pulumi CLI what is the runtime and the name of the project. Then we had a stack. A stack is the class that included the resources, and it's an independent instance of the Pulumi project. I can have multiple stacks in my project, and I can do this by using Pulumi stack init and give it the stack name. Each stack could have its own configuration file, and I can use this configuration to change the different values for each stack. So I can use the stack to represent different environments, and I can say the location of the resources for the dev environment, or some of the hardware specs for the production versus UAT versus dev. I can add the configuration values to my config file using Pulumi config set, and then that will add the value to the config file for the stack. I can access those configurations using the Pulumi.config class. This will enable me to read those values from the code and using it with my Azure resources. If the values are sensitive, you can also pass additional parameter to mark that value as sensitive. Usually we don't want to commit sensitive values in plain text in source code. So if you would like to, but if you'd like to do it as part of some sort of testing locally or something like that, you can use a sense like dash-secret, and there are different options from Pulumi to encrypt these secrets as well. It depends on the provider that you are using, but just we don't want to save those in plain format. So those are like the key fundamentals that you need to keep in mind when you are working with Pulumi. It's pretty straightforward. You don't need to learn a new language or the basics of the C# or TypeScript or anything. You just use what you already know. All right, we have seen how would we provision our first resource, but usually we would have like a few more requirements. One of the requirements that I have had to deal with recently is how would I like to provision a storage account to host a single page application using the new feature of a static website from storage accounts. Just let me show you what I'm talking about. If we look here in this storage account, there is a plate here called the static website. That static website, if I enabled it, it asks me for index document and error document. Once I provide the parameters and click save, I should be able to get a URL that URL I can use to navigate and view the files hosted inside the storage account. So this enables me, if I have a single page application written in React or Vue or Angular or any other tool, I can host it in my storage account. And I don't need to create like a web application or a container to host my single page application. So how would I do this in code? You would expect that normally you would have like another property here called website enabled equal true from ARM APIs, but unfortunately that doesn't exist right now. And that's not a limitation in Pulumi. If you try to do it in any other infrastructure as a code, it doesn't exist. The good thing is Pulumi has provided another resource for us to use so that we can enable that website property. So let's try to do this together. And that resource is called storage account static website. Account website. And then we'll give it a name and we'll pass the parameters of that new, sorry. I used the render class here. That's it. Storage account static website arguments, and then we need to pass the parameters. So the parameters that we need to pass here is first we need to pass the resource group, and I'm using the same syntax. It's another variable, so I'm going to use resource group.name. I would like to provide the storage account. It's called the account name. And the two parameters that the portal asked me, which is the index document and it's going to be index.html and the error document, which is going to be 404.html. That's it. That should help me enable that website property in Azure. So let me just refresh this, and then we'll go run apply. So we'll make sure that nothing is cached. So it's disabled. It's disabled right now. Let's go run Pulumi up. I will pass an additional parameter here, which is yes, so that Pulumi will automatically go and provision the resources. Because it's a small change and I know what's going to be applied right now. So here you go. It's going to provision a new resource, and that's not an actual resource. It's just like a virtual resource. Behind the scene, Pulumi is going to go and find the storage account, enable that static website property using the Azure SDK. So if you look at the portal, right now we should be able to see the static website. Here is the URL that we were talking about. I can use it and open and verify that things are working. But we are getting that the requested content doesn't exist, which is kind of, I know it's working because I haven't uploaded any files inside that web container. That's why I'm getting the 404. But I would like to have things like in an easy way to determine if it's working or not working. So what I'm going to do is I would like to upload a couple of files, index.html and 404, so that when I test my application, I want to make sure that all of the configurations are written in the right way. So first, I'm going to create a couple of files to be uploaded. So we create prod. The first one, we call it index.html. And we're going to have building stuff school. And then another 404. And we're going to call breaking stuff is bad. All right. So we'll get back to the code so that we can start writing the code to upload those two files. So I have two files, so I can declare an array of files. And it's just normal C# syntax, nothing really fancy in here. And then we need to loop over these files. For each file, I would like to do the upload. So I'm going to go with the code snippet for each file in the files I would like to upload. So I'm going to use another resource from Pulumi called plop, and that resource enables me to upload files from my local storage into the storage account. And I pass a few parameters here, such as the plop name, resource group name, and a bunch of other parameters. This will enable me to upload the files from local to the storage account. But usually I'm a little bit lazy and I don't want to do a lot of clicks in the Azure portal also to find that URL to test. So if I were to use it from the Azure portal, I would have to find the storage account, go to the static website played, and then find it from here. Good thing I can do that in code as well, so I don't have to do all of this in the portal. And the way we do this is using what's called output properties. So output property is like a promise in JavaScript. It's a promise where its value will be available after the resources has been provisioned. So how would we declare output property? It's like a normal C# property, but we are using a generic type called output. And it can accept any other type. And the type that we write here is the actual value that will be available after the resource has been provisioned. We'll call it website URL. And then we'll mark it with an output here. And this means that we will have the value of that property printed on the console. So I don't have to go and do all of the clicks on the portal. So I'd like to set the value of this property, and then I should be able to good to go. So it's a normal property, and the value of that is available in the primary endpoints. Primary endpoints itself is an output property. So how would I access the value of an output property? I need to use a special method called apply, which will give me access to the value of the primary endpoints after it has been resolved or after the resources have been provisioned. So with that, I can access the web. And in here, I can see that I can set the value of this output property after accessing the web property from the primary endpoints. All right, let's go and apply that. So now, right now, I'm expecting 2 files to be uploaded from my local storage to the Azure storage account. And I'm also expecting to see the URL of the storage account on the console. As you can see here, the URL has been printed immediately, even before the update, because the storage account was provisioned in a previous stage. So the URL was already available for us. We didn't have to wait for any further steps. So I'll copy that URL, go to the Azure portal, sorry, the Azure portal, just my browser, hit in here, and here you go, I'm getting a response. I can also test the 404, and it should show me that breaking stuff is bad. All right, so now we have learned how we can start leveraging the capabilities of using real language and start updating the storage account with for loop to upload files from local storage to the portal. And it's pretty straightforward, nothing really new. You just need to learn what the resource that you would like to do and just yet another new class instance. But then after I have hosted that storage, created the storage account to host my single page application, when I was talking with another colleague, I found out that they are also would like to host a single page application for their micro front end. And I was like, okay, let me share the code with you. But to share the code, there are multiple options. There is the old way, which is copy paste all of these scripts and share it with them, or I try to make some sort of a reusable component so they don't have to learn about that website property that doesn't exist. They don't need to learn about this custom resource that Pulumi has provided us as a solution to the current limitation, how to have this convenient way of uploading a couple of files to verify the configurations are working. So I decided to build a reusable component to share it with them, and then they can use it easily. And this is what I'm going to show you right now. In order to build a reusable component, we just create a new class. So I'm going to create a class here. I'm going to call it public static web app. My class needs to inherit from a base class called component resource. And that component resource needs a special constructor. And with the Visual Studio Code, I can automatically provision that constructor. And the constructor accepts few parameters. The key parameters here is the type and the name. Type is what we see here on the console. This is the type. So usually the consumers of my class don't need to provide that value for us. So I'm gonna go and remove the type and we'll hard code it to be build stuff. Static with app. And then what I need to do is create or put all of the resources that I would like to provision in the constructor of my class. So I'm gonna cut all of the code that I have used previously and we'll put it inside my constructor here. I will need to have also that property in my class, so I'm just gonna copy it. Then I need to do a few tweaks for my code. The first one is I need to make sure that all of the resources are using right now resource group name. That needs to be an input parameter for my class where my class resources will be hosted. So I will go with the simplest approach right now, which is just a string. We'll call it resource group name. And then we'll update the resources that I have to use that particular parameter. The next thing is I can create multiple instances of this class. So this means all of the resources inside the class needs to depend on the name of that class as opposed to hard-coded values like SA here. So I'm just going to use name and the name here as well. And finally, for the plop storage, because we could have multiple static web apps, I'm going to go with name dash and the file name. And we are done with provisioning these resources. So how would I consume the class? Similar to any other class we have consumed previously. Var my web app, new static web app. I will just provide the name app, the resource group, refer to the variable, and we are done. How would I set the website property? In this case, my web app, first we need to say website property, website URL equal my web app dot website URL. And here we go. If I would like to provision multiple resources, I just keep copy pasting, like creating multiple instances of that. I can even put it in a for loop. So let's run Pulumi preview just to see how things looks like. Yes. Taking a few seconds, should show us list of the resources. We can see here that all the resources are going to be deleted because we pretty much deleted that code and we changed the name of the resources and everything. So we can see here, it's going to create a static web app and 3 resources or 4 resources inside of it, which is a storage account, the storage account website, and the 2 blob files. So as you can see, it's pretty straightforward to provision a storage, to create a reusable component from Pulumi. Let's get back to the slides to see where we have here. It's pretty easy to start working with Pulumi, but one of the key questions that I get from people when I show them this example of having the for loops and the resources is, doesn't that make Pulumi like an imperative approach back to the old school of having all of the resources? And to answer that question, I need to go and walk you through how Pulumi works under the hood. So generally, we describe our desired state with code using the new resources as we have seen. Then we pass our code to the Pulumi CLI. Pulumi CLI will go and check what is the current state. State is a simple JSON file that could be saved on a storage account, or could be saved on a local file, could be saved any place. At the beginning, the state file is empty, so all of the resources needs to be created. So Pulumi will go through a planning phase where it determines what kind of actions needs to happen when it's creating the resources, create, update, delete, even changing existing resources. Once it finds what needs to happen, it goes through the apply phase, which is talking to the actual providers and do the actions that has been determined in the planning phase. Finally, it updates the state with what has been provisioned. So the next time I apply changes to my code, it can compare the current state versus the desired state. And if you look at any other declarative infrastructure as a code solution, such as Terraform or others, you will find that this is the exact same architecture that is happening for these tools. It's using the exact same approach. So it's definitely a declarative infrastructure as a code solution, but we are just writing our desired state using code. And that's the key differentiator between Pulumi and other infrastructure as a code solutions. So far, I have been showing you how to provision or how to use Pulumi from my local machine. And most of the time, you would like to provision the resources using a CI or a CD pipeline. The good thing is with Pulumi, you can use the same command lines that the same commands that I have been showing you on my machine on your release or build pipeline. So this is a typical pipeline that you would have. You will have your infrastructure as a code. Then you run Pulumi preview command, which will show you the first part of Pulumi app, what kind of changes will be applied. Then you will have some sort of manual review, so you don't want to break production because of a mistake in your infrastructure as a code changes. Then you will go with Pulumi up, which will go and provision the resources on the cloud. One important decision that you would need to make when you work with these infrastructure as a code solution is thinking about where are you going to save the state file. If you are working on Azure, most of the time you will save it on a storage account. That's one option. You need to make sure that that file is secure and it's not enabled for public access or anything. Or you can use something like the Pulumi Servers. They also have their own SaaS offering where you can save the state with them. One more thing with the build pipelines and release pipelines, Pulumi has a lot of extensions and the plugins that have been built for the most common tools for releases, such as GitHub Actions, Octopus Deploy, Azure DevOps, and a bunch of other tools available. They have their own extensions that have been already built that makes it pretty straightforward to use Pulumi. So it's even making it easier from integration with the pipeline. You don't have to write like custom code or custom scripts. It just becomes really intuitive. So the example that we have on the screen right now is showing me how to use Pulumi with GitHub Actions to provision or to preview the changes for a particular stack. And in this case, I'm using the Pulumi SaaS service to host my state. So I'm passing the Pulumi access token and Pulumi config passphrase. And in here, I'm using the environment variables to tell Pulumi which Azure subscription to connect to apply the changes. So it's pretty straightforward and it's easy to apply these commands. I'd like to recap what I have covered today. Pulumi is an infrastructure as a code tool. It supports multiple clouds and it's an open source. It supports multiple languages such as C#, Go, and Node like TypeScript. It's a declarative infrastructure as a code. We just write our desired state in C# or real programming language. There are three key concepts that you need to keep in mind when you work with Pulumi. Pulumi project, which is a directory that includes the Pulumi.yaml file. The stack, which is an independent instance of the Pulumi program, and you can use it to represent different environments and the configurations of those stacks. We can apply abstractions in our infrastructure as a code using common abstractions based on the language, such as classes and functions. And we can easily integrate Pulumi with CI and CD pipelines, either by using the Pulumi CLI directly or by using the extensions that has been built by Pulumi and the community. That's all what I wanted to cover today. The resources for the slides for this presentation is available on this bit.ly link. I will share it also on after the talk on Discord. You can learn more about Pulumi from their documentation and GitHub examples directory. I also have a Pulumi demos repository on GitHub that have some examples, and what we have seen today is also available on the GitHub repository. That's all what I have. Are there any questions?
Yes, I do have a question actually. Somebody was asking, is there a way to generate the Terraform scripts out of the Pulumi code you're writing?
The Terraform from Pulumi or Pulumi from Terraform?
I guess why not both?
Yeah, I get, yes, there is actually there is a tool that enables you to convert Terraform code to Pulumi. I haven't used it myself, but it's available. Like I didn't use it in a production environment, but it's available on Pulumi. You can use it to convert Terraform code to Pulumi.
What about the opposite? Can you do Pulumi to Terraform then?
I haven't thought about that. No, I didn't see it. I didn't see a tool to convert Pulumi to Terraform. For me, I usually think, how would I get from Terraform to Pulumi? So I'm not aware of such other tool.
Yeah, I mean, it's like just knowing the architecture, like it's probably theoretically possible because underneath the hood, all it's doing is invoking Terraform. I just don't know if anybody's written a tool for it yet, or if there's a built-in function to do so.
There is no built-in function. There might be someone. I need to check it out. I am not aware of a tool that has been written already to do that.
No worries. Thank you for that talk. It did answer. You know, one thing I was wondering is when you end up writing, you know, a lot of these .NET Core functions to handle building your infrastructure and all the rest. Do you tend to, how do you handle, you mentioned a little bit of your CI/CD process. How do you handle like testing out the changes? Do you usually have developers like have their own like dev environment? Like how do you do that workflow process for them to do it work?
Yeah, unfortunately, I didn't have a lot of time to cover the testing today, but the testing in Pulumi, there are generally with infrastructure as a code, you have unit tests where you can write like actual unit tests in C# with XUnit or NUnit to verify some of the properties of your code. For example, if you have a convention that each, each resource needs to have the product name or the department name, you can do this with unit tests because these values are available in the code. But you can also do like integration tests where you can, Pulumi has what's called automation APIs, which basically it enables you to provision the resources of your infrastructure code, verify the properties of the provisioned resources, and at the end of the test, you tear down those resources. So you don't have to have a specific environment. You can have like an ephemeral approach where you have with each test, you can just run these verifications. Obviously, the integration tests are going to be slow because they are actually provisioning real resources and it will cost you some money.
That's actually really cool. It's a really nice feature considering one of the biggest hassles is trying testing your stuff. Well, thank you so much, Hossam. I really appreciate it. I don't see any more questions. So with that, thanks everybody. We'll see you here shortly for the next talk.
Thanks a lot. Thank you.